Kubernetes, the future of cloud native development. It is based on the version 1.34. Earlier, I have shown you all the examples with the demos and explanation with 1.33 version. Now it is updated, and now I will show you the cloud native is the future of applications built for the cloud and scalable, super fast. So Kubernetes is the king of orchestrating the containers like Docker. The fact is 96% of organizations use the containers. So it is the power of Kubernetes. Giants like a Google and Netflix ready to master Kubernetes, and let's deploy our first application in minutes. So the three steps involved while doing this deployment, and number one, download Minikube for local Kubernetes and start it. Number two, write YAML file for the deployment of our cluster application, expose and access your application via the kubectl command. Now I will show you one by one all these three steps. And first step, so here I can you will see this the brew update. It is especially for the Mac. If you have other than Mac, so you can comment it below, so I'll explain for that also. Now it is the simple and brew update. It will update the homebrew version. If you are not installed, you can check out my previous video in my playlist Kubernetes tutorial, you will get it there. So brew install Minikube, it will install the latest version of the Minikube, that is you can see here the 1.341. so this is the latest version. So once creating the Docker container with CPU cores and memory here, and kubectl was created, see the exact version here. So kubectl, kubelet and kubedium. So kubelet is the Kubernetes client, command line interface for creating the pods and other Kubernetes objects, and kubelet is an agent which runs on every node in the cluster. Okay, right now Minikube will provide the single node cluster for your local. So this is absolutely fine for practicing and learning the Kubernetes. So but it is not recommended for the production version, and you will have different than this multi-tier Kubernetes version in the production version. So now let's see one by one. So this is the kubectl get nodes. Before that, you need to use Minikube start. Once if installation is ready, it will start the Minikube in a local single node cluster. So once it is started, you can try to get the nodes. You will see the Minikube ready. Now deploy our application. So here we can see, I will write it my pod deploy, okay, .yml file. I will show you. So here I have the API version, specify the Kubernetes API version, and kind is, so we are deploying the pod, so pod, and metadata we need to provide. Under metadata we need to provide the name, so name of the pod, hello. Under spec, this is the top level elements is API version, kind, metadata and spec. Under spec we need to provide the containers. I'll show you the containers. I'm simply giving the hello for your reference, sorry, not this, containers. And name need to provide. Under this you need to provide the name of the container. I'm just giving the hello, and image of the container I'll provide nginx. So is it will deploy perfectly for exposing our application and accessing? Let's see. This is the first step we need to go. So here there is a problem. I will show you with the practical demo, then you will get to know. So verify that my pod d.yml file. So this is the file. Now try to create it. You will get the pod is created. Then we will see my pod deploy.yml. So pod was created. Now get the pod. Let's wait for a while. It will create the container ready. Get pods. So one by one is ready. Now when we try to use the expose command, there is some problem you will get. I will show you that with the practical. Kubectl expose pod. What is the name of the pod? Here we are saying that hello. Specify that hello pod, and port you need to specify. It is mandatory. Port equal to 80. That means we are using the local. Type is equal to provide the service type, either node port or cluster IP. So No, cluster IP is default one. We need to provide the node port dot load balancer. I am using the load balancer B capital. So that's it. Now you will get the error here. What is this? Couldn't retrieve the selectors via selector flag introspection, so that cannot be exposed because of we are not specifying the label under the metadata. Clear this. Total get parts. In Kubernetes, once it is created, we will not be able to edit, so we are directly removing this total delete pod hello pod. Now to check if there are any services available. So only one service is available. So so we are already deleted the pod. We need to create that pod again. Kubectl, sorry, not cat my pod.yaml. So here we can see this. This is another file I have created just now. So label we are not specified. I will show you that also. Cat my pod.de.yml. See what is the difference here? Just now we have executed this, but we are unable to expose the application for accessing it. Okay, now here this is the updated one. Here we have seen that label application hello. So this one we can able to execute it. Now try to create it. Create f my pod.yml file. Again there is a typo. Give me a second. So pod was created. Now try to get the pod. So one by one is running. Now you can try to execute the same command again, exposing the pod with the application load balancer. Now it will execute it. See service hello exposed. Now try to get the service. Get SVC or service, anything is fine. See load balancer is running. 2 steps we have completed. What are the steps we are following? Step 1 in downloading, and step 2 writing a deployment file and exposing the application. So we are already exposed this application. Now we need to access that application via the URL. So for that you need to get the URL for the service hello. That use Minikube service or SVC, anything is fine. Specify the name of the service hyphen URL. You will get the URL for accessing the Nginx application. This is the URL you can access via the browser. Open the browser. Welcome to Nginx. If you see this image, the Nginx server is successfully installed and working. Further configuration is required if you have. This is the simple web application when you are deploying it. So Kubernetes architecture follows a master and worker node model consisting of a control plane, that is master node, and one or more worker nodes. I have taken the simple 2 worker nodes. So this is the complete overview or blueprint of the Kubernetes architecture. This is simple way I can explain. So coming to the master node, so this is the overall why does it have a master and worker node? So because of control plane, that is master node, is responsible for managing overall cluster and making global decisions. That means whatever the request coming from the end user, so it will make the decisions and pass the request to the you can say respective decisions it will take. Okay, now so coming to one by one, these are the components which will have the Kubernetes API server, a Kube API server, which is a front end of the Kubernetes control plane, exposing the Kube API server for the external users to perform the management operations. So it handles all the communication between the cluster and cluster components and external request. So via example from the kubectl command, whenever you apply this kubectl, so it is coming from the kube API server initially. Okay, then etcd. Etcd is a key value store, so that serves as the cluster single source of truth. That means storing all cluster data and configurations. So it will be key value format. It will store whenever you run the kubectl command, so the data will come from the etcd data store. Okay, then kube scheduler, so it is the scheduler job is to watches for the newly created pods with no assigned node. That means if there are no, if the newly created pod is there, so it will check the node availability and then placed on the node. Okay, node availability it will check and place the pods on that nodes. It is based on the resource requirements and policies and specifications. Okay, these are most important. And controller manager, so runs various controller process that regularly, I mean that regulate the cluster state. That means it will get the desired state if it is necessary. So which will include the node controller and replication controller here. So node controller will say check with the node healthy or not, and replication controller it ensures all the replications are running at all times. Okay, then external one more is the cloud controller manager, that is optional, either aws or azure or gcp. So now we will move on to the worker node. So worker node which will have this is the complete worker node 1 and 2. Okay, so kubelet, kubeproxy and pod is there. So kubelet we can say, so it is an agent in the every worker node which will run and communicate with the kube api server. Whenever the request coming from the kube api server, it will come to the kubelet, then it responds with the requested information. So it ensures that containers described in the pod specifications are running and healthy. Okay, then kube proxy, it is the maintains the network rules on the nodes. So whenever the request coming from the kubelet and it will redirecting to the, so that means it is the routing mechanism. It will handles the service discovery and load balance for the services. Then here is the pod. So inside the pod directly it will not create, so a runtime environment is there. So the container runtime engine we can say docker or rkt. So the software responsible for running the containers, example docker or containerd or crio, it pulls the container images from the docker hub and execute them within the pods. Okay, this is the pod. Then pods, so within these pods we have multiple containers. Okay, so pods are the single unit of work or smallest object that you create in the Kubernetes. This is the overall architecture about Kubernetes. So I hope this is very clear and beginner friendly. So what is pod here? Pod is nothing but the smallest object that you create in the Kubernetes. So basics of pod we will discuss, and types of pod and top level fields of pod YAML and init with multi-container pods with the real world examples with the demo I'll explain. So pod YAML, it is nothing but the smallest object that you create in a Kubernetes. Okay, so the smallest object you create in Kubernetes. Types of pods. Types of pods in the sense a pod can have the single container and multiple container. So we can say pod can have two types of pods. That is single container pod then multi-container pod. So single container pod can have only one container, that is single image, and multi-container pod which will have the multi-container pod with single image. I will give you the simple demo. Suppose I was directly going with this, and do not worry about this, and we will explain with the demo. Spec, under spec we need to have the containers. Okay, containers. Under this we have only one name, that is suppose I have njnx container and image was njnx. Okay, this is the single container, so we can say single container pod. Single container pod. Likewise we have one more container, that is multi-container pod. So we can take the same example. multi-container pod, we have two images with two containers. I can give Redis and image was Redis. Okay, this is the multi-container pod, we can say. So the simple and easy to understand. I will give you the complete YAML file for the single container and multi-container with the demo. Now you can understand this, what is spec and what is containers. I will show you with the demo wise. And we have two types of pods, single and multi-container. So what are the fields, attributes? Top level fields or attributes. Okay, so we have top level fields, that is for API version, you can say. So this is the version of the Kubernetes API we are using to create the pod. Okay, now the second attribute was kind. So in Kubernetes there are multiple objects like deployments, config maps, secrets, pods. So likewise, what type of object you are trying to create? Suppose if it is a pod, we can say pod. Suppose is it a deployment, we can say deployment. Likewise, and metadata. So this is the one more kind of attribute, that is top level attribute, API version, kind, metadata, then finally spec. Okay, these are the top level attributes. Under metadata we can specify the labels, that is the naming conventions, whatever we can give for the pods, and we can use the namespaces, and for the matching label also we can provide under the metadata. And we can see this spec. I can give you these examples. So under spec we can have the containers names with images and commands, and as well as we can say some other configuration like commands with special permissions like resource limits and all, we can say under the containers and within the resource request limits. So these are the top level fields for the pod. So init with multi-container. So why init containers and multi-containers are, what are the difference? And so init containers are specialized containers which will have the init containers attribute. Okay, so which will have the init containers attribute. Under that we need to provide the names of that. So likewise, what we provided the containers under containers here, the same way we need to provide the under name and image. So those are the specialized containers which will start before your main container application will run. That means so these are the containers, right? Suppose there are two containers. Okay, before that it will start the init containers. Suppose you can say download configuration, download config, I can say. This is just a name. Okay, not worry about this, but this is the actual name I'm giving is as a name, not worry about it. So this will start first, and once it is completed then it will go with the main containers. Okay, that is the init containers. And multi containers we already discussed here, and now we can use the demo with real world examples, so you can have a thorough understanding on this. So I will open my terminal. So before moving on to the practical session, you need to check out this, how you can install the Minikube for your Mac. So you can just simply search for, you can open YouTube. So you can simply type Kubernetes for Mac. So you will find the video here. So this is the video which will be updated of Code with Chandra. So you can find this one, and this is easy installation guide for to set up the Minikube at the step by step. And once you completed this Minikube setup, so you can open your terminal, start with Minikube start. It will start the Minikube. So I will show you that also. So you can see this Docker desktop here. You can see this Minikube is starting. Now wait for a second and we will try to update this. Okay, now Minikube is configured with the default namespace by default. Okay, now we can try to get clear, try to get the nodes if it is ready or not. You can check by, so single node Minikube cluster is ready. Now you can start practicing. So before moving on to this, I will show you the way. There are two ways to create the pod: via the command line utility, that is without YAML file, or with YAML file. So I will show you with the YAML file first. Vi, so my pod.yml. Okay, this will open the VI editor. So if you are not sure about what is VI editor, I have the updated playlist for the Linux as well in my YouTube channel called Chandra. You can find it there. So now it will open the file. So by default it was there, so I will remove all this content. Okay, no. So I can remove all this content. So once you gone through the basics of a pod, you will try to update here. So okay, I'm using this EAPI version v1. This is the Kubernetes version, and kind is, what is the kind here? Pod. Okay, P capital, that make sure P is capital. And metadata, right? Under metadata we can say name. So this is the YAML syntaxes. You need to keep two spaces. Okay, if it is any sub label is there or sub topic is there, you can use this two spaces, then only it will identify as a YAML file. Otherwise you will get the syntax error. Name, I can say my pod. Okay, now I can move with the spec. Under that, containers. So what containers we used here? Name, I will give you this. So what are the containers we have used? Nginx container. You can use the same as it is. Okay, Nginx container and Nginx container, and the image was Nginx. Okay, this is the single container pod. So we'll try to execute this, save it. If you want to save this file, escape :wq. Okay, now if you want to verify this file, you can use vi cat or cat command. It will show you the what are the content available on the pod. Okay, my pod.yml. Okay, now you can see this is the pod.yml, and you can try to execute with the kubectl command, create -f my pod.yml. See, pod.yml was created. So what are the Nginx container, right? We have that. You can see this, what are the containers here. So you didn't see any containers here. If you open it, this is the configuration for the Minikube. Not worry about it, you can go through this. Try to get the parts with the kubectl get parts. So commands you can note it down. This is for creating the part if you have ready with the YAML file. So once it is executed, then you can try to get the parts. You will get the, so pod, my pod was running. This is the single container pod. Suppose I want to execute with the two pods, you can try to edit those element with the kubectl. You can clearly observe this. I'm using this directly, create get pods and edit pod. I am also using kubectl edit pod. What is the pod name here? My pod. Okay, try to edit here. You can edit the image, Nginx image name is Nginx container containers. We can add one more file here under container section, -name redis container. It is the image redis. Okay, Okay, now save it. So it is not allowing, so we need to delete that file and you have to create. Okay, so once the pod is created, it is not allowing in Kubernetes, it will not allow. So if you want, you can try to delete that. Okay, cancelled, no valid changes are applicable. What you will do here first, kubectl delete pod my pod. Okay, so it is trying to delete the pod. See, pod deleted from default namespace. Try to clear this. Now you can try to get the pods, get pods. So no resources available. Now try to edit the pod, vi mypod.yaml. So here you can update one more container. Name of the container Redis. You can see, for your reference I am giving the container, otherwise it is not required. And image was Redis. So we have two containers ready, and now we'll try to save it and execute with the help of kubectl create -f mypod.yaml. So it was try to created the pod, my pod. Now you can try to get the pods. You will get the two pods with Redis and nginx. It will get pods. It is waiting, and so decide and ready. So if you want to check the logs of this pod, how these are creating internally, kubectl describe pod my pod. Okay, now we will see the list of events. Under event section you will see this. So successfully assigned the default mypod to Minikube and pulling the image nginx, it will pull the image from the Docker hub. So created the container, nginx container was created. Now it is pulling the image Redis image. Again you can see, so it is still pulling the image Redis. So wait for a while, it will show you. Once it is ready, you get pods. 2x2 running. Now you can see this Redis started also. I will show you that also. See here, first one, pulling the image Redis and successfully pulled and created the container and started the container. These are the steps which involved internally before creating the containers. This is the clean informative. Now kubectl get pods. See, 2x2 are running. Okay, Redis pod. And so, but actually you will not create the pods manually in Kubernetes. So it is the wrong way, because for beginners I'm explaining this, but you do not create the pods manually, but the deployment will create the pod for you. In upcoming sessions I will show you how to create the deployment. Now we have seen one way to create the pod using the YAML with a single container pod and multi-container pod. Now we will create the single container pod using the command line interface using the kubectl run nginx pod -image equal to nginx. So this will simply create the nginx pod, okay, without using the YAML file. This is the simplest one. See, pod nginx pod was created. So how easy it was. Kubectl get pods. See, nginx pod was created 9 seconds ago. Hope you got this, and we'll say one more, that is init containers. I will show you one more file, init container.yml. So what is init containers, you know? So init containers are specialized containers. It will start before your main containers will start. Okay, API version kind is pod metadata. The metadata we can specify the name of the pod. Here we can specify the name of the pod. I can say init pod. You can use naming conventions. Under spec, in spec we can specify the init containers. This is very important. So why we use init containers, if any, before your application is starting, check that database is up to the mark. That means database is started to recover the any issues before starting your application. This is very important. That means your application is ready before making any request. Okay, either database or front end or back end. Okay, now we can use the name in conventions. If a name nginx, giving it is a name. Okay, and the image was nginx container, nginx init, I can say. Now we'll move on to the main containers. Main containers, under containers, hyphen name redis image was redis. So we have init containers 1 and main container is 1. Before running the redis container, the init container will complete, then only it will move on to the redis container. Save it. Now check the file content. So this is the file content we have. Now we will try to execute kubectl create -f init container.yml. Now I am hitting this. So here is the pod was created, but actually the internal things will happen while describing. We'll look into the logs. Kubectl describe pod init pod. So why I'm giving this init pod, while creating the pod we are given the name, right? Init pod, those name you need to provide it here. And the pod type of the object you are trying to describe, and a describe command with the kubectl. We'll see the logs. So pulling the image, successfully pulled the images, and here it is the nginx container that is the init container. Okay, created container is nginx init. Now we will try to get the pods. Kubectl get pods. See here, it is still under the init stage. Okay, so once it is ready, then only it will move on to the next step, otherwise it will not be running. So this is the examples of, here is the summary. So what is pod? The smallest object you create in the Kubernetes namespace. And why types of pods? Two types, single and multi-container. And this sample code base I have given, and top level attributes of the pod, and init its multi-container pods. Examples with the demo I have shown you. Discuss about today's topic is role-based access control, that is RBAC. So what is role-based access control? Why we would need that in the Kubernetes security? It is for best practices. We can restrict the access to the Kubernetes clusters and roles. Based on the roles we can restrict who can access what cluster and what context. So based on the core security feature in Kubernetes, that helps you to control who can do what in your cluster. Okay, so the simple definition I can give you this here. Core feature in K8s security. Core feature in a security that can control who can access what in your cluster. So this is the simple definition. The beginner friendly explanations I will give you, and go through this till end of the video, so you will get the full-fledged knowledge about how you can create it. Okay, so what is RBAC in Kubernetes? Coming to the Kubernetes, So RBAC in Kubernetes allow you to define the permissions, that is roles, and assign them to the users or service accounts, that is bindings. So first we will create the role, and the role binding will be created, that either service or binding objects. Okay, this ensures the principle of at least privilege. That means users get only the permissions they need. Suppose if the production user will get the admin privileges with the full access. Okay, for the developer we will get only the development and deployment access, but not in the production access. Likewise we can go with the restrict the access. Okay, key factors we can see. Key factors. Okay, key factors here will come to the role. So what it contains, a set of permissions within the namespace. So set of permissions, I can say, within the namespace. So each user within the namespace, in the sense that suppose the production namespace, development namespace, and testing namespace. Likewise we can different namespaces are there. Likewise we can go with the role based access. Within that namespace only he can able to access. That's why we can restrict the access. And cluster role. So within that cluster role hook, so like role, but applies to the cluster wide. That means node can able to access pods and Kubernetes objects like deployment replica sets that can able to access within that cluster. Applies to cluster wide objects, cluster wide K8s objects. Okay, and it is coming to the role binding. We have role, and we have role cluster role, and we have binding object also. So binding object, it binds a role to a user or service account within a namespace. So it binds the user or service within, I can say, account, service account within the namespace. Okay, it will not allow you to the other namespaces. Only suppose if the production namespace, it will only allow the production namespace, and if it is a testing or it is a development, so within that namespace only it can limited access. It will give based on the binding object. Then it will come to the cluster role binding. This is the cluster role binding. It will binds a cluster role to the user or service account, that is a cluster wide. This one also cluster wide. Binds a cluster role to a service or user account. I can say service or user account. Not account. Okay, so these are the key factors, key components, I can say. Role, cluster role, role binding, and cluster role binding. So these are the four key components, and we can say, so for we'll try to create one example with the read only access for the pods, the help of define a role. Okay, with the YAML file we can see. So likewise how we can create the Kubernetes objects like pod. Likewise we can create example API version. So since it is a RBAC, right, we need to use the RBAC authorization. And back dot authorization, we need to provide authorization dot K8s.io/v1. This is the API version which we need to use. So earlier we have created for the parts v1 or for deployments replica set apps v1. Likewise we were not using here, since it is a role based access control. We need to use this security API version. and the kind is role. So what type of object we are trying to create here is a role, and we can say there is metadata. Under metadata we need to specify the name of this pod reader. I can simply for your references. So since it is pod level access, right, we are going, so pod reader, and namespace we can say, I can give you default namespace only for this. Then we'll go for the roles. So since it is a RBAC, we are not using any spec containers and all. We are not going to get any images, or we are not going to get any get the or pull the images from the container registry or Docker Hub. Since it is internal best practices, we are going with that. And since so we use API groups. So earlier in a short version I have given you the rules for in every rule there are 3 components, that is 3 fields available: API groups, resources, and verbs. So API groups is which is applicable for, if you are not mentioned anything, that is the default one for core objects. This is the default one for core objects like pods, deployments, it's not deployments, replica sets and all. Okay, under resources we need to mention pods. Since it is a pod level access, we are mentioning the pods. And verbs, here we need to mention, and what access we have to give to this user pod reader account. Only we have the reader access, that means get, list, watch. So he doesn't want to create, or he doesn't want to edit that, or he doesn't want to delete the pods. Okay, we are only giving the get access, list access, and watch access. So these are the only access we are giving to this user, and this is the simple example which I have given. And once the file was ready, we can create with the help of below command, kubectl apply -f. So I can give you this example file name as okay, pod reader.yml. okay, pod reader.yml file I have given. So keep in mind that you need to apply this pod reader YAML file while creating -f pod reader.yml. okay, so it will create the reader access for the pods with the role pod reader role. okay, and next we will move on to the next topic, create the service account or binding account. So that means service account, what it will do here, read only. So we can directly create the service account with the help of kubectl create. Next I can say create a service account. So using the kubectl create service account, read only sa.yml. So keep in mind that file names are different. okay, this is pod reader I have given, the read only sa.yml file I have given sa-en default. So we are directly creating, instead of going with the YAML file, I am directly creating this one. So you can use YAML file also, it will take some time to get, and this you will not able to understand. You can simply go through this command, it will create the default namespace with the service account read only sa. okay, next what we can do is bind the role to the service account. That means bind the role to the service account. So for that we need to write one more YAML file, that is called read pods anything. The file name was read pods role binding dot. For your reference I am giving these naming conventions, so for simple understanding. Okay, then you will go with the again API version RBAC. Back authorization K8s io/v1. If any typos, you can kindly ignore that and you can access or you can edit on that. Since I am giving bit faster, you can say this is for role binding. Okay, R capital, here B capital, that is the role binding object. You can go with the metadata again. Metadata, any typos you can simply ignore it and you can correct it. Sorry for that inconvenience. And metadata we can give the name as read pod bindings. Okay, for naming conventions I am giving the namespace is default namespace. So even if you are not specifying the default namespace, it will be coming to the under the default namespace only. And here we need to specify, here we are giving the rules, right? Here we need to specify the subjects. Instead of rules we need to specify the subjects. So hyphen kind, what subject we are specifying here? So service account, because we are binding to the service account only, right? So we are specifying the service account. Then name was, give the service account name, read only. Yes, here what we have given here. Keep in mind this, these are the important note points while creating this service role binding. Services here. Then namespace, again coming to the default. Next one more is there, that is for the role reference. Role reference we can pass here. So what is the role reference here? Kind is role reference, in the sense we are creating the kind for role, right? So you need to specify the role here. Guys, this is simple example, that's why I'm creating very small and simple. And name was, so name was pod reader you have given, right? So initially what we have given here, pod reader we have given. The same way we have to give the pod reader here also. And you can use the API group. What is the API group here? RBAC dot authorization dot K8s dot io. So now this is the file, and what we have to do, so apply the role binding with the help of kubectl apply command. Next apply the role binding. Okay, with the help of kubectl apply -f read pods role binding, right? We have given read pods role binding .yml. So this is the file name which we need to keep it here, and you can see if any spell or typos. Okay, it will create the binding object. And now we can test the permissions. Now we can test the permissions with the help of kubectl authentication. K9 means can able to access list pods hyphen as equal to system. You can go through this as it is so that you can able to identify system service account. You need to mention service account colon default namespace, then read only SA. Now you can see that if you have the access, it will give you the response as a yes. Above command will give you the response like yes. Okay, and so try checking the something unauthorized, like deleting a pod, if you have the access to that or not. So you can try to delete the pod. Kubectl auth can I delete pods same hyphen as equal to system colon service account default read only SA. Same concept we need to pass. So within this file you can able to delete the pod. You can try this, it will give you the answer like no. So this way you can try to check the permissions. What we have did here, so we have explained the role based access and we see the key components, and we have given the pod reader, that is the YAML file example. And once the file was ready, we have applied that command, and next we created the service account which can identify the role reference, and then next we are applying the role binding object. So we have created the role and we have created the role binding object which will bind to that role, and we can try to execute these commands with the help of either we can delete the pod or either we can see the pod, okay, get the pods. This way we can try to access K8 security role based access control. So along with the key components which we have role, cluster role binding and cluster role binding. So we have seen one example. So this is the pod reader access, and we see that the binding object for that pod reader, that we have created read pod binding, that is the service account which we created for that binding the pod reader, and we have created the commands for which will execute for role and role bindings. Okay, for your understanding I will go with one more explanation. Since we have in the development environment or testing or production environment, we will say, so I'll create one more file called developer-role.yml so that you can easily understand content of the use API version. That is since it is a RBAC, right, we need to use RBAC authorization RBAC authorization dot K8s.io/v1. This is the API version which we need to use under the security feature, that is kind is what we defined earlier. So that is role. So we need to create the role first and then role binding object, then we need to execute the commands. Okay, we'll specify the role as a developer. Okay, so now instead of going with the rule spec, we are going with the rules. So we rules which are contains the API groups, resources, and verb. We already discussed about this concept in here. You can see this API groups, resources, and verbs. API groups is so if you are not specifying anything within that square brackets, that is the default one for the core objects like pods, deployments, and all. Suppose if you explicitly specify anything, that will come under the whatever the specified Kubernetes object you are mentioned within the square bracket, that is the API group, and resources will come into the pods, deployments, configs, secrets, etc, etc. So verbs, so which you are going to, which operation you are trying to do within that resources. Okay, under roles we can specify the API groups. Okay, so now we are not specifying anything here. We'll say that is the default group. So under resources, so we can say pods. So developer can able to access the pods. Under next verbs comes under what he will do with the pods. He can create the pods. So we can list the pods. He can get the pods, and he can edit the pods, edit or update, anything is fine. He can edit the pods, he can delete the pods. So we are giving all access with respect to the pods for the developer role. Okay, next we can say one more group, API groups. Here also we are not mentioned anything, so we are going with the default one, resources. So under resources we can use config map. Config map. Okay, under verbs, what he can able to do within the config maps, so he can only create the config maps that you can mention. Okay, this is the role which we created for the developer, and once the file was ready, you can try to create. Next, you can create or apply with changes using below command. kubectl apply -f developer role .yml. Okay, so you can use one more also using the kubectl create -f developer role .yml. So this both are same. Okay, don't confuse with the commands. I'm giving the clear-cut explanation. Now the first step is ready. We created the role, and we have created the we have applied the changes. So it was created the role. Now we are going to create the role binding object for the same. So next, create the role binding object. Okay, so with the help of developer role -binding.com, I can say .yml. So go with the API version as it is, RBAC authorization. Check if there are any typos. Okay, authorization K8s IO/v1. This is the API version. K8s. you need to specify the role binding. Whatever the role we have created, for that we are creating the binding object. Metadata name you are passing as a same. You can use as a developer role binding, or depends on your or else you can use dev user. Dev user developer binding. Okay, you can use the same name as also, that is also fine for. Next we create subjects. So API version kind metadata subjects are the top level fields. Even role reference also, that is the top level field. Under subject we need to specify the kind is user. So which user you are trying to array, which user you are trying. Okay, next one is name. You can specify the name for dev user like that. Okay, and we can say API group, that you need to specify the API group, that is RBAC API group. Remove this one, and subject we have created. Okay, next we will go with the role reference. Use role reference. So here kind is role, so what we created earlier for the developer. Okay, name is what we have given here, developer. You need to take this one, and next API group same, or back authorization. You copy this command. So now role reference role binding object was ready. Then create a role binding. Next role binding using below command. Okay, kubectl create -f. What the file name we have given here? See, copy that entire file name. So we have applied these changes. Even you can use one more option called apply also. Both are fine, and you can use instead of create, apply. So role binding object was created. So what's the next step? To view the roles in Kubernetes. Use below command. I can say kubectl get roles. Okay, to view the role bindings, kubectl get role bindings. Okay, we are so we are reviewing the roles, and we are viewing the role bindings. To view more detail about the role and run with the help of describe command. So as usual, when we applied for the pods, right, for describing the pod with the doing any changes, or if you are going with the in detail and in-depth information about the pod, so we are viewing it, right. Likewise we can use kubectl describe role, use the role name which we have created, so developer. Okay, So this is the kubectl command. We are describing the role which you want to describe and the name of the role we are passing. So likewise you can use the role binding also, role binding which you are passing kubectl describe role binding. So is there are any typos we can keep in that, so you can verify that before going to create role binding, then specify the role binding name. Okay, here we are specifying the name as a dev user. Okay, that is the dev user. Where we have given this name, sorry, this is the name, we are mistaken. So dev user binding. So this is how you can get the roles. You can get the role bindings, you can describe the role, and if you want to check the logs, you can use the kubectl logs with the name of that role or role binding. With the help of that you can check with that. So okay, this is how you can try to practice with the actual commands, and I have given you the two examples for your better understanding. And if you have any doubts you can comment it below, so we'll clarify your doubts, and I am here to help. And so Kubernetes in 1 hour, Kubernetes in Telugu, Kubernetes in Hindi. So local languages will not allow in the Kubernetes officially they won't allow you to communicate with the interviewers, and also they will show HD cinema for you. Okay, learn from, if you are good in basics then you will get to know easily with the advanced topics. Okay, that's why I'm clearly giving these examples and all. Thank you all. So far we have seen that K8 security, a role-based access control with key points, and one example for authorizing the role-based authentication, that is a role, and with the help of role binding object we have created. So we have with the help of kubectl apply command we will see that I have seen that how to create after creating the role and role binding object, and we have seen that developer role also. Now we will see the cluster role and role cluster role bindings which will have the same security mechanism in the Kubernetes RBAC, that is role based access control. With the help of administrator we can see cluster admin, and cluster admin role bindings we can see now. So how do we authorize the users to the cluster wide resources like nodes and persistent volumes? So this, you know, that is where you can cluster roles and role bindings will work in the Kubernetes cluster. So okay, consider for example we have a cluster admin role can be created to provide the cluster administrator permissions to view, create and delete nodes in the cluster. Okay, so the key similarly we have that storage administrator role can be created to authorize the storage admin to create the, and delete or view the persistent volumes and claims. Okay, this is how the it will be working. So we can see one example for cluster admin role and cluster admin role binding. So if you want to refer few things and key points, you can refer with this documentation, and we can see now directly I'm going with the cluster role admin role. Okay, you can define cluster admin role.yml file. So this is the file which we have created. So you can as usual you can write with the version, API version. So you know, right, RBAC authorization. So earlier we have discussed this one, authorization dot K8s dot, since it is a security mechanism we need to provide the REST v1. So kind is, you know, what is this role, cluster role, you can mention that cluster role, and metadata you can provide the name for that role. I can say cluster admin since it is a cluster. And next we need to specify the roles instead of specification. Earlier we have seen that in the pods and deployments and all spec. Now here we need to provide the roles. Under roles, what are the key attributes we have now? API groups, resources, and verbs. API groups. So you need to provide, by default it is allowing. We are not mentioned anything here. That means it is the default one. You can go with any resource in the Kubernetes cluster. So resources we can mention, which needs to be, it is either pods or deployments or what. So this needs to be done with the nodes. So since we are creating with the nodes, we can use nodes. So here instead of nodes we can use pods, deployments, config maps, secrets. Likewise we can use, based on that we have to provide the rules and verbs in the sense we need to provide which access we have with that. So here we have provided the nodes. So with the nodes, what he can do, cluster role we are providing, right? Nodes will create the nodes according to his permissions. He will create the nodes and he will list the nodes and he will get the nodes. Within the codes you need to mention, and he will delete the nodes. So we have given the roles as well. This is one simple cluster admin role, and we need to create the one more YAML file called cluster admin role binding. Then we can map this role to the role binding object. Okay, so we can say cluster admin role binding. Okay, not YAML. Now we can go with the pay version as usual, or back authorization. Authorization dot K8s. So specification you need to mention completely, not in the short forms. And kind is cluster role binding. We have seen cluster role, and then we can use binding. Since it is a binding object, we need to provide the name. We can use cluster admin role binding. Since for your understanding I am giving the naming conventions, you can go through it and you can watch a complete video. Until unless you will go through the videos, you will not able to catch up things properly. And we need to provide the, not rules here, it is a binding object, we need to provide the subjects. So under subject we need to provide the kind for whom we are creating. This is for user, not dev user, only user. Okay, user, and we need to provide the name as well, cluster admin. Which user we are going to provide? Cluster admin. Okay, binding object we are trying to create, this is the name of the user. Then API group, not API version, API group it is. Okay, we need to provide the full or back authorization dot v1. The next step is, so subject has mentioned, but for subject we need to provide the role reference, right? Role reference. Okay, then here we need to mention the kind as a cluster role. Which role we are giving to him? Cluster role, and name was cluster administrator. And API group is same again. Okay, or back. Guys, don't confuse with these things. And initially we have created the cluster admin role, and for that role we have created the binding object to map this to that role. Okay, since it is a subject is a user, cluster role, and administrator we have created. Okay, this one. Now what we will do here is, this is the role details, this is the role details, this is the user details, and a few more things is there. The context we can see that in the upcoming sessions. Okay, now we'll try to execute with the help of the commands. Which command we need to provide this? First you can see that same commands as usual. You can go with commands like kubectl create or apply, create hyphen f. Use the options like, I'm giving both files at a time. You can try it one by one, and first you need to execute this one, and first you need to execute this one. Next YAML file and kubectl create hyphen f, cluster role binding information you need to provide. So now these two files will be generated, and if you are working in a Minikube local, so some CRDs is required, custom resource definitions that you need to be installed, that you don't worry about now. So you can go through this for the concept wise, for the interview questions for DevOps engineer, so that should be fine, and you don't worry to practice and all. And if you want, you can set up a local setup and do it in yourself. If you have any questions, you can comment it in the comment section, so thumbs up it. Now once you created this role and role binding for the cluster admin, you can see with the help of kubectl get cluster roles. Okay, so you will list out all the roles which are available within the cluster, and you will see that. So if you don't want to use the header information, that means once you get the details right, like names and CPU resources consumption, any other which node it has to be assigned likewise. So you don't want that information, you can use kubectl get cluster roles, not head, get cluster roles hyphen hyphen, no headers, no headers. Okay, space wc word count hyphen l. It will only count the list of resources available in the cluster roles, and it will display the number. Okay, so even if you don't want that headers and cluster same for cluster role bindings also, you can use instead of this, and cluster role bindings. Okay, this is also same cluster role bindings. So if there are any typos, you can correct it. Since we are auto populating, that will be something like okay. And now you want to get the separate list for the cluster role, can use get kubectl get cluster role bindings. Grep command is especially will use to get the separate file permission or separate files for searching it, and it will give you the results. Cluster admin, say okay. Likewise you can search it, and for now okay, these are the commands which you need to execute it after completion of this cluster admin role and cluster admin role bindings. So we'll see the commands which are available now. So that's all for now. You can go through the videos and practice it well, and you can watch thoroughly, and every day just for 30 minutes to 1 hour you can practice this. You will better to understand this Kubernetes concept. It's very basic, and it's a matter of simple and easy concept.